Welcome back from the coffee break. This session is the Internet Security session, or actually the first of the Internet Security sessions, and we have 3 presentations for you in this. First up is Robbie Mitchell, who is the Senior Communication and Technology Advisor at the Internet Society, but he's also previously worked for APNIC, producing the APNIC blog. But he's going to be talking about indexing Southeast Asia's internet resilience. So I will hand over to you, Robbie. You have 25-30 minutes.
Thank you, Kevin. Thank you all. I'll do a test, Brad. Yay. Good morning, everyone. Thank you very much. First, I want to thank the organisers and selection committee for putting on this great show, Apricot, and inviting us to present, and to yourselves in the room as well to come and listen to me and my fellow speakers in this session. Today, I'll be talking about the Internet Society's efforts to help decision makers understand the global internet's health, availability and evolution, and gain your feedback on how we can improve this as an industry. What I hope I leave you here today with is that it's worth keeping abreast of the resilience of your and your neighbouring countries' internet ecosystems, as there is plenty to learn from the strengths and weaknesses and plenty of insight that you can offer as network operators to improve the overall health of the internet. So as an overview, I'll put this topic into context, and I'm going to discuss 3 case studies of how internet resilience in North America, Europe and Australia has been compromised in the past 20 months. I'll then share a snapshot of Southeast Asia's internet resilience, focusing on its security resilience to align with this session's theme, and highlight the strengths and weaknesses of several countries. Finally, I'll discuss the need to improve national and regional internet ecosystem data and resolution, which includes security-related data to allow decision makers to make more informed decisions on improving the internet's health in their countries. So the Internet Society has been running its measuring the internet project for about 3 years, or a little over 3 years now. The outward-facing product of this is the Pulse platform, which curates open source data to examine internet trends and tell data-driven stories. Our current focuses are tracking internet shutdowns, government-mandated internet shutdowns, the state of deployment of critical technologies such as IPv6, DNSSEC, TLS 1.3 and HTTPS, the concentration of infrastructure services and markets, and finally the resilience of the internet in more than 170 countries. Regarding the last of these focus areas, we developed an Internet Resilience Index, or IRI, which I might refer to through this presentation. So the IRI collates and tracks open source internet resilience metrics to support policymakers in the decisions. The IRI draws upon more than 20 open data sources and uses best practice methodologies to calculate a snapshot of a country's internet resilience in terms of its infrastructure, its performance, its security, and its market readiness. I'll speak to each of these pillars as we go along and the metrics that are underneath them. But before I do, I've mentioned how I want to put this all into a bit of context and show the importance of measuring and advocating for internet resilience. So we'll uncover a couple of recent incidents that have made the news internationally. So the most recent one of these happened last October in Australia, where a minor technical slip-up by the second largest operator Optus caused 1/3 of Australians to lose internet and mobile connectivity, and disrupted emergency services, hospitals, banks, and the public transport services. While there's been no root cause analysis forthcoming yet, although there's been plenty of commentary, including that of Jeff Houston's a couple of days ago, as well as my colleague Aftib Siddiqui. And he noted shortly after on the Pulse blog that the warning signs of Optus's lack of resilience compared to other carriers in Australia were apparent, most notably their disengagement with local peering. So it's not necessarily what the issue was, but just a lack of redundancy and resilience there that led to a more wide-scale issue for the rest of Australia. So while that might have been a strategic business decision to disengage, it overlooks an opportunity to bolster network resilience through diverse connection paths. While the IRI doesn't offer that insight into a network's level, it shows how concentrated market share is, which you're familiar with Australia and a lot of countries for that matter. Telecommunication market is pretty much a 2.5 horse race. Given the wide-ranging severity of this outage, the Australian government quickly ordered an inquiry to examine roaming and emergency services impacts and whether rival telcos can offer access to the services during network shutdowns. It also investigated the adequacy of Optus's communication on the day of the outage, something I'll touch on a little bit later as well. So our second case is across the Pacific, and it also shares a chief executive officer, no longer at both. The Rogers outage in July 2022 spread across Rogers's cable, mobile and fixed line services and directly affected all of its 12 million subscribers and indirectly prevented all businesses nationwide from being able to accept debit and credit transactions, affected several government services, including Canadian Border Security, impacted the timing of 1/4 of traffic signals in Toronto, and denied access to 911 emergency services, so similar to Australia in that respect. Overall, it was estimated to have cost the Canadian economy nearly $142 million USD, and Rogers itself $150 million USD in customer credits. Like Optus, Rogers never provided a post-mortem of the outage, except for noting that the outage resulted from a configuration change that deleted a route filter, flooding certain network routing equipment and resulting in a core network failure with broad impact. Rogers has acknowledged that it needs to plan and implement network separation of wireless and wireline core network functions, and it's currently spending $260 million US to that accord. If we look at the IRI profile for Canada, we can see that upstream provider diversity is about the same as Australia, but its market diversity is quite a bit higher. It will be interesting to see how this figure changes given the recently approved merger between Rogers and Shaw Communication. Like Australia, the incident bore government scrutiny. It spurred similar government policies to that of Australian government is seeking, and to reduce the impact of future incidents when they occur. The final incident I wanted to highlight happened in Italy about this time last year, when nearly, again, 1/3 of the internet users in the country were left without internet connectivity for 5 hours. Like the other two incidents, the ISP in question haven't been forthcoming with a root cause analysis. Still, thanks to analysis from the community, including my former colleague, Max Ducci, it was apparent that the issue was related to a lack of redundancy on the side of TIM, and its upstream provider, Sparkle, combined with a lack of local peering. As seen in the Hurricane Electric BGP toolkits, TIM relies only on Sparkle for international connectivity. If we compare this to Vodafone Italy, it has 5 upstream providers. So this setup provides plenty of redundancy when one of those upstreams has an outage. If we look at Italy's IRI profile, it's interesting to note how upstream diversity ranks highest of all these 3 case studies, which does point to a limitation of the index and metric, and I'll speak more about that shortly. Okay, with all this in mind, let's dive into the internet resilience of this region. So Asia collectively has the second most resilient ecosystem of the 5 regions in the world, with Oceania only a percentage behind. And if we drill down into Asia's sub-regions, Southeast Asia and East Asia equally have the most resilient ecosystems. Again, if we zoom in further, we can see Singapore leads all comers by a fair margin. This isn't just for Southeast Asia, but the whole region and globally. It's ranked about 4th globally, and it is the only country outside of Europe to rank in the top 10. This is the IRI profile of Singapore. So all these metrics cumulatively make up its overall index score of 72%, which is being an index ranked against other countries in the world. So there is never a chance to get to 100%, just to clarify that point. At first view, there are no real weaknesses. It ranks first for all pillars in Southeast Asia. The pillars, again, reminder, the infrastructure, performance, security, and market readiness. For the latter, it actually ranks 4th globally, market readiness. But if we were to be picky, we would call out some of its security resilience metrics when compared to its neighbours. Sorry, where'd that one go? Oh no, you got the old one. That's all right. We'll work with this. When compared to its neighbours, where are we going? Now we have to find one. Oh, there we go. Myanmar's a good one. Myanmar. So Myanmar is doing fantastically well in terms of its DNSSEC validation, and its routing hygiene ranks one of the highest in Southeast Asia. This is really going to be annoying now, so let's work with it. Let's have a look at Thailand. So Thailand ranks, if we go back to here, Thailand ranks about middle of the pack overall in its internet resilience. And what I was going to do is drill down into the security aspect of it and rank it by that. And if we did that, sorry, this is going everywhere. We actually see a lot of change. And you can do this with the tool, if you select security, Singapore will still stay the top of the pile, but Myanmar, which has an overall 45% Internet Resilience Index score, actually jumps up to 2nd in overall with a roughly high 60s for its security resilience. Laos also jumps from 42, being 2nd last here in overall, to 3rd when just looking at the security resilience for a country. The point I'm trying to make about this is we've talked about the pillars. Some countries are prioritising some parts over others. And for these other countries, they've recognised security as their major aspect that they want to improve on. And if we did go back to Myanmar, we can see that, again, they're doing fantastically well with 71% for security, but all those other ones are below 40%. in terms of their resilience index scores. And there's nothing wrong with that. I mean, you have to start somewhere, and that's a priority for them in terms of their resilience. Again, yep, second in Southeast Asia, DNSSEC equal first in Southeast Asia, and routing hygiene first in the whole of Southeast Asia. Thailand, again, was middle of the pack for overall internet resilience, and it's about middle of the pack as well for its security resilience profile as well. If we were to dive into it, a lot of that has to do with its IPv6 adoption. So it's enabling technologies. Although if we do also look at the one above that, the secure web traffic, which is HTTPS usage in country, that's at 47%. But the big one I've got a box around is DNSSEC validation. It's great to see that the CCTLD has signed DNSSEC, so that's DNSSEC adoption, but DNSSEC validation is the next thing that they need to work on, with only being 8% at the moment. We're going to skip ahead a little bit here. So the limitations. What I've shown here is merely a guide, and some of you may have scoffed at some of these scores and sources, and you may have your own data that shows something different. What we're trying to do with this tool is to make these open data sources more readily available to decision makers, so they can make sense of them in demonstrating the various aspects that make up the health of the internet. By no means do we say use this as a source of truth, but it does provide a digestible view of what is going on to help you, and especially decision makers, identify weaknesses and then hopefully do your own research to validate if what these measurement systems are seeing is accurate. To this point, we advocate for greater localized data sourcing and sharing, which provides greater resolution to what is really happening at the edge. This is also the first version of the index framework, and we plan to extend it to include new metrics, some of which, and replace old metrics, some of which are becoming redundant and no longer refreshed by the sources. And also new pillars. We're also looking into how resilient countries' internet ecosystems are to climate and natural disasters. So to conclude, understanding what's happening upstream and beyond your country's borders is equally important as knowing your network's health. You may want to know that the networks you're peering with and the routes you're taking are resilient, so you won't be up for any sudden costs to purchase capacity on the chance of any mishaps. Some of you may also be servicing customers in other countries or are considering doing so. Again, knowing the internet resilience of these countries and the links between them can help you understand the risks and where you might need to invest. Furthermore, having an insightful national measurement system in place helps validate this sort of data that we and decision makers are becoming more reliant upon to address the weaknesses in the ecosystem. This is something that we sought to develop in parallel with the original iteration of the IRI as part of the Measuring Internet Resilience in Africa project, or MIRA for short, and involved creating and deploying MIRA probes to several countries throughout Africa. And we're always looking for opportunities to expand this work in other regions too. At the same time, a nod to our RIPE friends as well for all the great work that they're doing collecting data through the RIPE Atlas project, as well as to UNI and other measuring probe systems out there. And while it's unfortunate that others have mishaps, you can learn from them, and you should share your own information and successes so that others can learn from you too. As the adage goes, it's not a case of if, but when, but the impact doesn't necessarily have to follow those I've discussed already. Finally, if you're interested in keeping abreast of our project, please subscribe to our monthly newsletter or email us to discuss opportunities to partner or contribute to our blog. I've also shared a link to the methodology of the IRI for those interested in the sources and calculations. Thank you.
Okay, thank you, Robbie. Do we have any questions?
The slides on the website will be a little bit different. It's all good.
Yeah.
I have a question. Can you show the details how you get all the measurement results? Do you have some details? You get all the index, how you measure them, how you collected the data?
Yep. So yeah, I'll go back, scan that. Methodology.
Yeah.
Yep, it's a open source methodology. It's based on a research paper, so it has a breakdown of all the indices and the calculations associated with it.
Thank you. I will check it.
I think there's a question over there. You want to state your name?
Hi, good morning. My name is Adison from Interlab AIT. So you mentioned about the resilience index, right? So my question is about, have you considered about a numbers of internet provider, ISPs, and monopolies in case, for example, like in some country like the ISP, the fixed or broadband ISP also acquire or providing the mobile ISPs as well. So this kind of thing, they're gonna be
Yep, so market diversity. Market diversity and upstream provider diversity are the two factors associated with that. This also can be used in conjunction with another products that we have, which is the country reports. And that shows a percentage, the number and percentage and rank of the number of ISPs per, I think it's a breakdown of 10,000 or 100,000 population for the country.
Okay. And second question is about the methodology. So you are using the probe to do the measurement?
No. So all this information is collated from all open sources. It's about
Live.
20 different open sources. Yep.
Okay, lives or the KIDAS probe?
Say DNSSEC, IPv6 adoptions, an average of APNIC, Akamai, Google, and Facebook, 5 to 10 kilometre reach, which I know a question's about to come. That's from World Bank, ITU, GSMA, whatever is out there and open and has a scope of about 170 countries. That's the hard thing as well. There's a lot of really, really good data out there at a country or regional level, but because we're trying to do this as an index globally, that's a big limitation of it at the moment. So that's why we say, use this as a guide, do your research, bring your data to lay on it to validate if there is weakness or if it is a success as well.
All right, yeah, thank you.
Hey, Dhruv, I think you were next.
Yeah, thanks. Dhruv here. My question is related to the shutdown ones, the pulse shutdown tracker.
Yep.
Do you have any success stories on how that has changed the minds of policymakers anywhere? Or we have the data, I point this to it, and we said that we are doing this so that we can inform the policymakers and the folks about it. Is there any success stories that ISOC could share?
The closest to success we've had is working with the Iraqi government last year, and we worked with the telecommunications branch of the Iraqi government and advised them about the impact that shutting down the internet would have during national exams, and they took that on board and made a press release saying we won't shut down the internet. We have done in the past. We won't shut it down around exams. However, the Education Board was not happy with that, and they took that to the ministerial and got it overturned. And in the end, Iraq happened to overtake India for the most amount of shutdown events in 2023, whereas India has always been number one by a long margin. And all those shutdown events were related to exams. They were only 4-hour shutdown events, but yeah, close to success. In the end, you can only talk to the decision makers that you have a connection with. But again, we view our part in internet shutdown advocacy, or to advocate against internet shutdowns rather, as it's a team effort that we have to work with other partners. Access Now is a great proponent. We're great value. They do amazing things in that respect. We're trying to help on the measurement side. At the same time, there's some really good measurement projects out there. IOTA, UNI, and Cloudflare Radar do fantastic work in terms of measuring it, making it known that it's happening, and then these civil groups. And we also have our chapters advocating from a grassroots to hopefully influence their governments.
Thanks, Rob. And I think it's a responsibility of all of us in our rooms who advocate for internet that we do our bit in convincing, and it has to be ground up until there is actual population support for this is an unacceptable thing that our governments do. This is not going to change. It's an easy tool they have. They like to use it. The saying goes, if you have a hammer, everything looks like a nail. So that's exactly what happens.
Exactly. Yeah, and I think it is actually against humanitarian law to shut down the internet. So you can take that to your government and say, we know you're ordering us to shut down the internet, but this actually violates international law. So if you're happy to be sued on that account, then that can happen. There is becoming a lot more legal action taken against governments for shutting down the internet. So hopefully maybe that will pressure them in terms of thinking twice at least. Is this going to be worth it in the long run? John.
Jonathan Brewer, New Zealand. I just wanted to comment not on your 10-kilometer fiber reach statistic, which I bullied you about for a couple of years, and hopefully will die soon.
It will.
Sorry, I'm channeling Jeff Houston. I wanted to comment on the TI Sparkle issue and the fact that you really need to be cautious when you say a network lacks diversity because they're not peered, because Sparkle is the same company as Telecom Italia.
Yeah, it is.
And it's a very normal practice to have a transit ASN and to have an ASN that only uses the transit ASN for transit. You'll see this pattern all over the world in big carriers, including in New Zealand with Telecom Spark, which uses Global Gateway International, a wholly owned subsidiary, for doing all of its peering and interconnections. So it's not, and I'm reading this article, the importance of redundancy about this outage, and I'm just scratching my head. Like, you need to look deeper into just the picture, because that doesn't mean that TIM is not redundant. TIM is incredibly well connected. They really are. Okay.
Thank you, John.
You're welcome.
All right, so thanks very much, Robbie.
Thank you. Yeah, and as I said, we want your feedback on this. Whether it is a useful tool, please have a play around with it. Come back to us if you have metrics as well that you think would be useful. We're all ears on that respect. Thank you.
Okay, thank you. Okay, to move to our next presentation, actually, Shoko, yes, you are here. Very good. So next presentation is by Shoko Nakai. Hopefully I've said that correctly, who is an information security analyst and incident coordinator at JP-CERT Coordination Center. She's been working there since 2010 with primary responsibility for providing coordination and assistance for cybersecurity incidents related to Japanese and global markets. This talk is on IoT devices leveraged in cyber attacks and how botnets are created and used. So over to you, and 25 minutes.
25 minutes. Okay, thank you. Thank you for the introduction. My name is Shoko Nakai from JP-CERT Coordination Center. I'm security analyst and incident coordinator. So I'm not kind of like working for ISP and also like a domain name service, something like that. So, but I would like to talking about IoT devices today, because so IoT devices has so many devices has been part of the botnet right now. So I would like to share our findings based on our coordination. So. Okay. This is my presentation. I want you to see the actual internet like users by malware and attackers today. So maybe with my talk, you will be able to get insight and to understand and how to deal with like ever expanding botnet. Okay, before talk, I would like to a little bit about introduce my JP CC. JP is a national CSIR in Japan. We have 20 over years of experience, and also our primary founder is Ministry of Economy and Trade and Industry, but we remain non-governmental and independent organization. Okay, we have three main services. First is a respond, and the second one is watch, and the last third part is a prevent. So I would like to first focus on watch. So watch, we run the internet monitoring system, which is called the Tsubame system. Tsubame, we just started in 2000, I'm sorry, this is wrong, I'm sorry. We started in 2008, not 2023, 2008. And now we have 161 sensors and installed in 27 countries. And we recon TCP and UDP and SMP. So this sensor just doesn't send a packet, it's just receiving the packet over the internet. Oh, wait. Okay, oh, I'm sorry. Okay. This is a rough configuration of Tsubame system. So as I mentioned before, the sensor just received the packet and dropped that based on the IP tables and passed to our database. So we are able to see the actual internet trend by investigating each single packet. This is observation that I got from this Tsubame system. This is a number of packets received, one sensor per day. So what I want to hear with this slide is to increasing, every year increasing. So next time is 2024, it will be like a close to 9,000 packets, one sensor per day. And this is observation regarding packet source status for 2023. You can see most are coming from the America and Europe. But I want you to focus on a little bit about Asia Pacific region here on the right ratio, mainly from China and then Singapore, Hong Kong, Singapore, and Korea. So I just wanted to explain in a real internet status right now. So many unwanted packet flowing. So with my talk, I wanted to reveal the cause of this unwanted packet, where it's coming from. This is because IoT. So today's my topic here, 1, 2, 3, 4. First, I would like to talk about a little bit IoT malware, and with that, I will raise 2 case studies here, and with that, I will take up the countermeasures, and finally, takeaways. Okay, first, IoT malware. I picked up 2 malwares today on Mirai and Gobrat. Mirai, it's been continuing developing since like 2016. I think everybody knows Mirai, right? And this is the history of Mirai malware. I wanted to compare with both in Japan and in abroad. So, you know, the Mirai source code reprinted on a GitHub, and after that, Tsubame began observing Mirai activity in Japan. It's like end of 2017. And unfortunately, beginning of 2021, Japan-based attack launched. So because IoT infected with Mirai malware. This is a Mirai features, really common features. It's ELF malware, and it's leveraged so many vulnerabilities. And also, I found this like some interesting features from the source code. It said that the initial sequence number and then the destination IP match. So, okay, next, Gobrat. I think this is pretty new because we found this Gobrat last year, 2023. This is a timeline, and GovRat, it's likely to continue to be developed in the future. It's keeping developing. And also, my colleague wrote about this GovRat malware. So if you want to get more detail, you go visit this blog. You can get more detail. Okay, GovRat features. This is written in Go language, and it's communicate with NCNC server via TLS, and also this sample various architectures like ARM and MIPS as well. Okay, from here, 2 minutes. I will release 2 case studies. It's going to be so easy to understand what's going on over the internet, real incident based on that. Okay, so from this phase, almost the phase are handled by the response team that I belong to. And I would like to share the before detail. This is our main handling work. And first, we receive the report from the constituency, and we do start the investigation and make a situation assessment. And we do analyze the malware and access log everything. And we do forensic too. And we try to make a consideration what is the factor of this incident. Okay, Mirai. In 2021, we received a report from several ISPs. They said that they are likely DDoS launched, and so they are seemingly like involved in this incident. Okay, so same period of time, we received the internet users too, and the one case from nursing home, and she claimed that the circuit breaker trapped and the router repeatedly rebooted because of 100% CPU usage. She don't know what's going on over the internet. So she also explained to us like, actually the security camera was installed in their nursing home, but she couldn't access the control remotely. And also there is no internet connection. But other internet users as well explained to us, like same like there is no internet connection, no longer available. And also other person said that there is something access to the overseas IP address. And so we made a map based on the report what we heard. And this is not happening only one ISP, but it's happening to the several different ISPs participating in one DDoS attack. So we just started a survey like 3 ways. First, we check the system, the Tsubame system, and also we utilize the external services like Census and Shodan, and also we access this target IP address via HTTP to figure out what is actual services running on the suspect IP addresses. So this is a result from the Tsubame. It can be seen so many 23 TCP ports. And this is a picture where we got from by accessing IP address via HTTP. So many IoT devices are running on the suspected IP, and also most are DVRs. So with that all information, we talk with these distributors, like product distributors, and they explain. And they also tell us that they already received the same claim from their consumers, and they started to investigate their equipment, and they finally found that possible root cause. So I got a picture from the distributors, this picture, and this picture shows the dynamic DNS service function was abused, and crafted by wget command to access external IP address to get something bad files. So we hypothesized how to stop disinfecting DVRs. First, break into DVRs and change the dynamic DNS settings from the manufacturer specified to the third parties. And then enter the wget command in the domain name input box and execute the wget command to the access external IP address. So also we were able to obtain the other wget command from distributors in the box. And I wanted to compare with normal condition and abnormal condition from here. And this is a normal condition, and internet users can access this DVR portal without any problem. But abnormal, the DNS server cannot get IP address because the DVR, besides providing IP address, DNS services, it's connected to the CNC server by wget execution. So consequently, internet users couldn't access the DVR portal because there is no IP address access to. So we retrieved the wget files from the VirusTotal to analyze this file, and we confirmed this is Mirai malware and their vulnerability information used for the target in the blue box. And also we found two different processes this malware has. One is bug command, and then another one is authentication scan command. The first bug command, once the DVR received a command from CNC server, and the DVR starts DOS. But the DVR not directly to receive the CNC command from CNC server. There is a SOX proxy file between the DVR and CNC server. So the DVR actually connect to get through this in proxy 5. And there's a 3-bug command first end on their process and to start initiate the DDoS attack and also abort those that has been carried out. And then the another one is authentication information scan command. This process occurs under SSH, and malware creates a random IP address to connect it to break into the another IoT devices. And also the this malware hard-coded username and password is like a credentials. So once SSH authentication is successful, those kind of credentials is sent to the report server that's controlled by the attackers. So the attacker can use those kind of credentials over and over again. And so I would like to make a list of factors to be considered. First, the ability to spread the infection. What I mentioned before, authentication information scan command, it enables the infection successful spread because the credential was valid and used to use for the victim of the devices. And so those kind of information store used for the break into the another IoTs. So probably it increases the probability of device breaking. And there is a factor 2, Mirai botnet structure. Botnet hierarchical structure makes it very, very, very difficult to get into the real structures. So as I mentioned on the right, there's so many proxy file information hard-coded malwares, and sometimes it changes a lot. And so that kind of situation really hard to get inside and to understand everything what's going on around the Mirai botnet. So factor 3, this is about business. Since we talked with this product distributor, they revealed that manufacturer was out of business. So the following concerns should be unconsiderable, like vulnerable areas cannot be repaired, and no firmware update, and no guarantee of safety of domains used for a dynamic DNS service. So I make a picture for easy understanding under the situation under the manufacturer in question, because the particular manufacturer served as OEM manufacturer. So this impact not only one DVR, the IoT device, but all different kind of IoT devices, and so the impact becomes like so destructive. So I would like to add one more possible risk here about domain use for dynamic DNS, because I mentioned before this manufacturer is already out of business. So discontinuation manufacturer like businesses, but unfortunately they provide domain name for their DNS services, so still alive right now. And probably they use for the consumers DVR right now. And once the attacker targeted this domain and twist root, and all DVRs configured will be controlled by the attackers, and lead to the malicious side to be infected, right? And so this is a fuzzy record. This is a real fuzzy record, and you can see this domain is still alive, and its expired date will be this year, June 2nd. And so no one knows who's gonna rename this name again. And also, most worst things is that maybe the registrar, they don't know who it is. And next, GovRat. We reported in 2023, and he said that their router become controlled by the other person to participate in something bad things. And that this router was the ASUS router. At the time, the web UI was exposed to the one side. And this is revealed. This information was revealed and published by NICT, a security researcher. And they said in the previous version, the remote connection function was intentionally enabled when the smartphone access to the router. Okay, this is presumed step 2 infection. The first exploit the vulnerability of this router, and it creates a SSH key to communicate with the CNC server via TLS. And then once receive the command from CNC server, and the routers start scanning toward the outside of the network. So we got from the malware from the reporters, we analyze this malware, and we confirm this is GovRat malware. And also we confirm this following checks at startup. And it checks the IP address and the MAC address of itself, and it checks the uptime by uptime command, and also it checks the network communication status as well. And also we confirm the 22 other commands that are executed by the CNC server's command, and for example, to obtain machine information, and also to start SOX5, and to execute the FRPC. This is the first reverse proxy client. So it's enabled to communicate with an CNC server, client server, and server. Also, there is a factor should be considered. It's like authentication breach. This is a really common way to the attacker use for break into the router. The first one is authentication breach via dictionary attack, because this is really simple password. And also vulnerability on the web UI, and also the factory authentication, how to call it in the malware. I'm sorry, in the devices. So it allows to the person to get into the router. Okay, factor 2, levers of vulnerability. At the time, this ASUS router was vulnerable, so this router led to become like a botnet. Okay, from here I'll take the countermeasures based on the case studies. I list the 4 countermeasures, like possible measures here. First, check the IOCs and to dig into your access log if unwanted access occur or not. And if there is something bad signal, like, so you need to just reboot your IoT first, and then check whether this device is vulnerability in their firmware or not. And so you had better to report to the adequate parties as well to coordination. And if you wanted to, if you wanted to report this phenomenon to this manufacturer to examine their equipment, to get them now understand that this is vulnerability exists on your equipment. Okay, from here I would like to share some IOCs for you. And first, Mirai download location we observed by honeypot we run. You can see this the left ratio Mirai download location in 2023. We got to 923 IP addresses in 1 year. So it's spreading globally, and searching log based on those kind of IP address, it's so impractical. So I'm not gonna recommend to do that. But new things that I found that focus on the Asia Pacific region, and so malware download location located in China, followed by the India and then Vietnam. Okay, there's another IOCs here regarding Mirai malware. As I mentioned in the first slide, based on the original malware source code, its initial sequence number and the destination IP is matched. So I think this is kind of true because I have had the kind of same experience when we investigated a packet. This is true, kind. But as you know, this malware source code is already public available, and so everyone can obtain and modify the source code. And so I would say that not all packets is subject to this rule. So sometimes different. And also, this is IRCs regarding GovRat malware. We provided through GitHub. So if you wanted to dig into your access regarding there is a GovRat malware or not, so you can use this info to check with that. And also, if you want something bad things, and you can go to this list to share to check that whether firmware is vulnerable or not. Also, if we want to report a dark party here, but I mentioned here visit to the tech and manufacturer website, but I think it's kind of challenging because manufacturer will ask you to more detailed things or to clear explanation of what's happening. So in that case, I recommend you to go to the national system in your country first. Maybe they may be help your support. I mean, yeah, part of your help. So this is really good. RFC 9996 can be helpful. This document defined the machine possible format security text to help the organization describe their vulnerability disclosure practices. So this works very well, not only for a security researcher, but also for a manufacturer in order to improve their product security. And also, there's another alternative. We run Tsubame. We can provide a data, so you can take proactive measures against infected device in your own network if you want. Okay, takeaways. 3 takeaways: sharing the IoT observation result to you today, and also I introduced the how IoT devices can be used as a bot and based on a real incident, and also I suggest for our bottleneck countermeasures too. Okay, in a nutshell, looking back at the situation I described today, and an internet-related product aims to provide useful function to the internet users, but reality, unfortunately, it's not true. I mean, it was used to, it's being used for abuse for internet space right now, unfortunately. So I'm trying to make a map for easy understanding surrounding IoT. This is not really related to IoT manufacturers and also service providers, internet users. Both are really connected to these issues. So if you, I'm just thinking that to make a reliable and a clean internet space, we need to tackle the bottleneck really seriously. So to come true, I want you to a little bit look into your network. This is clean or not? Is this something that happened? If you want to care, to check your network. Sorry, to check your network. Okay, this is talk. This is all my talk. Thank you.
Okay, are there any questions for Shoko? Because if there are not, I have a question, 2 questions perhaps. So you mentioned that there was one of those devices was a DVR that's the manufacturer is no longer in business. So you have very limited options to upgrade that system. So what would you suggest is the solution? What's the approach when you find these devices that are just no longer maintained anymore? How do you deal with that, or what would your suggestion be other than just to take them off the network? Because people have invested significant money sometimes in these devices.
Yeah, this case is really hard to we are still considered how we handle this incident right now, because these manufacturers are not working. I mean, they decided to stop their working, to stop their businesses. So we could not reach out them by talk, and we never talk with them right now. So we are thinking about this to disclose this. If you are using that kind of devices, just replace the other DVRs. This is a best good way to stop being a bottleneck. But this is kind of, if we, like a national CSR, recommend the end users to replace all DVRs, who's going to pay for it, right? So this is another problem, and so we just to understand each single internet users who use for that kind of DVRs, to recognize that what kind of DVRs they are using for protecting your as your security. So with this, my talk, I would like to show that each single internet users as well as security service providers, because service providers sometimes distributed that kind of equipment to the internet users sometimes. So we wanted to talk with the security service providers as well to real internet status right now. So there is no best answer yet. But we want to understand the internet users and also the service providers as well, that what kind of equipment you are distributed to the internet users. So that's the way that we can.
Yeah, I mean, I do realise it's a difficult question. If some manufacturer's out of business, it's very difficult to address that. But I do think this is a growing problem, because I know certainly that I've got quite a few devices at home which haven't been updated, and they're from major manufacturers like Sony. They're not small, insignificant, small providers, but I haven't had updates on that equipment in many, many years, and I know that this is a potential attack vector, and how do we ultimately deal with this? It's a difficult problem.
Yep.
Okay, if there are no further questions for Shoko, thank her once again. Okay, that then brings us to our third and final, but by no means least, presentation. So this one is going to be given by Yin Chao, who is a technical solutions architect at Akamai, who has more than 20 years experience in the video and network industry, starting with the first DVB-T network in Southeast Asia, but then working at Cisco, implementing video streaming. But he's currently working for Akamai, helping to protect and deploy a robust streaming architecture, including protecting APIs from attacks. And that brings us on to the topic of this talk, which is strengthening API security in network operators.
Okay,
over to you.
Thank you. So yeah, so the purpose of this talk is to make you to bring awareness that there's this new attack vector for APIs. So today, APIs are proliferating because, through digitization, through machine-to-machine communication, and as network operators embrace automation, NetOps, more and more APIs are available, and they can be available on the internet. So these APIs needs to be secure, and of course, you need to know that there's this new attack vector for API security. So before we start, just a quick example, right? So for example, if there was this attack against an account where you could configure your BGP, but of course this was through a password. But imagine if you had an API and the API key was leaked. So an API key is also is something like a password, but it's an access key where you put it to a program to access the API. And if this was done surreptitiously, you would need specific tools to detect if that API was accessed in an anomalous manner. And I will show you a few other examples. So yeah, the API security environment is now proliferating. More APIs are being deployed every day. This is true because of digitalizations, because of end user clients proliferating. However, existing application security solutions don't really cover for a specific type of API abuse, which I will show you. As a result, API abuses and related data breaches will nearly double by 2024. And yeah, this is just a description of what type of API can be within your organization. So frequently we talk about two types of API. One is East-West. East-West API are usually within your boundaries of your organization. So this can be, let's say, one service calling another, or one business unit calling another business unit APIs, or different microservices calling each other. So this is what we call East-West. The other type is called North-South. This is where you open your APIs to outside users. And you might open it to, let's say, partners. So if you open it to partners, usually it's authenticated. You let them have an API key before you can use it, or you can open it to consumers and users as well. Oops, wrong. Yep, yeah. So this might be authenticated, and there might be some APIs where you don't need an access key to access it. So that is the B2C part of it, the bottom part here. However, there's a form of API abuse that can happen beyond your usual security solutions. So today, I think if let's say you have some infrastructure, it's quite common for you to have let's say a WAF or bot mitigation. So at the end here, so this will protect you against what we call signature-based attacks. If it sees, let's say, a user agent from some malware, you will block it. If it sees, let's say, there's a SQL statement within the API string, it will block it. So this is blocking just purely using a signature base. You might have DDoS protection. DDoS protection protects you against, let's say, a volumetric attack. If there's sudden burst of attack, it will block it. And today, because of the proliferation of having cloud workloads, you might have a cloud security solutions. So it might be a cloud security posture management. So it scans your cloud APIs to see whether, let's say, you have overly permissive permissions, you have left some disk unencrypted, that sort of thing, and then it will alert you, and you can change it. But today, if you have an API and your developers publish APIs, you're of certain size, you might have an API gateway. This API gateway is to provide authentication and authorization. But beyond that, let me now explain. There can be a class of attacks which can all these solutions doesn't catch. So let's say you have a B2B partner, you give them a key and they go through they are authenticated via your API gateway and they are authorized to use a certain gateway. So once they are calling your APIs, they could perform a sort of various type of abuse. For example, they could try to harvest certain data. So maybe they can access their own data, but because of some weaknesses in the way the API was implemented, they are able to get another person's data. And they do it in a, let's say, low and slow manner, so it doesn't trigger any other protection. So why might they do it? Maybe they are compromised themselves, right? So this is a quite common use case, a quite common abuse. I mean, let's say people accessing an API, and they find they can access users' data, and they start harvesting it low and slow, and they finally collect, let's say, millions of records, and then they sell it on a dark web. The other potential problems could be account takeover. So again, through some weaknesses in the way the API was implemented, they might be able to change a parameter and get a token for another user's account. And again, they can access the user account and, of course, do malicious things. Again, every API call they make looks like a normal API call, only some parameters and the context is different. And that is why existing security solutions can't catch it. And I'll go through some examples in a bit. So this is another real-world example. So a large mobile network operator had a data breach where millions and millions of their user record was stolen and sold. So the root cause, although it was not official, but the root cause was said was there was an API they used to stand up and it was exposed. And it was exposed a few years before. So this API was a testing API. They had no authentication authorization mechanism. It had no rate limiting. And it allowed people to get user information. Customer's ID also was stored in a weak format instead of UUID. What this could mean is like they were stored in a sequential order, like 1, 2, 3, 4, 5, 6. So people could guess the ID. And in the end, somebody collected millions of this data and they released it. And then it was a big thing, and then they discovered they had this open API. So it's true incidents like this. That's why API needs to be secured. yeah, this was a hypothetical example I said in the beginning. So let's say if you RIR provides an API interface to, let's say, manage various things, and if this got abused, whether through a partner, whether through a compromised person, then hackers can cause havoc if you don't have a tool that can monitor anomalous behavior. So this is a real example. So this is not related to network, but just a Uber. So here, Uber had two different APIs, seemingly unrelated. But through these two APIs, a person could take over anybody's account. So the first API the security researcher discovered was AdDriver. So he did a post request to this AdDriver, and he could use any phone number. But of course, since it's not authorized, it will return an error message. But what the API did wrong was that it returned an error message with too much information. It gave UUID of the person he was trying to add. So UUID is like a unique ID, usually a unique identifier for a user. And this researcher also found out there's another API where if you put in the first UUID, gets constraint details, you can actually get an access token to that account. So this means that he can compromise anybody's account. Because once you get access token, you can access his account already. And if you look into the details, so this is just, let's say, a request response capture. You put in the user phone number, you get back the UUID. And then the second API, you put in the UUID, and you get back a lot of PII information, including the user token. Once you get the token, you can access the user account. So as you can see, in this example, the individual API calls itself doesn't manifest itself as something malicious. These were just seemingly innocuous, innocent API calls. So your existing security solutions doesn't catch it. Yet, somebody could use these two API calls to take over another person's account. So this is what we call, let's say, a logic style abuse, a low and slow logic style abuse. And because the proliferation of API, because of this number of attacks against API is being increasing, OWASP, this non-profit organization, has come up with a list of top 10 API abuses that's happening today. And this exhibit two of the top 10. One is API 3, excessive data exposure, because it releases the UUID. And the other one is something called broken object level authorization. We'll go to the next. Yeah, another very quick one. This is Schoolio, another data exposure. So here, Schoolio is a school app in German where he had a lot of student information, student PII information. So what happened here was that the old API, which gives out PII, was deprecated, but they still left it open. So they wanted people to use the new API, but they left the V2 open. So the V2 was open and this was unknown, or they didn't realize it was still open when they released the V3. As a result, people got the profile ID from V3 and used it in the V2 to get PII data or student information, and it became a data breach again. Yeah, so they collected lots of information, then they sold it on the dark web. Another very quick information, Coinbase. So yeah, this is very quite interesting. So Coinbase is a crypto exchange. You buy and sell currency pair or cryptocurrency pair. So here, the malicious attacker found that there are 4 parameters in the API call to sell a currency pair. First is the currency pair, the transaction, the source wallet ID, and the target wallet ID. But what he found was that you could put any currency pair here. The backend system didn't really check that whether you had that currency in your wallet. So you could sell currency which you didn't have. Obviously, this is a very big vulnerability. So when they found out, they shut down the exchange for a while. And another quick use case, this is a Venmo. So Venmo is a social payment app. And when you do a payment, just for the social element, the API will query what are the other users around you making payment at the same time. So it will just give you around. But what a malicious user found out was that this API had an undocumented parameter. So usually we call things like this shadow parameters. So they discovered if you put a since here, you could get all records from that that time. So this is a time, an epoch time. You could get all the records on the time. And again, you know the story, right? I guess they scrape all the data and of course try to release it or sell it. So yeah, just to reiterate, as you have seen here, all the examples I've given are APIs which abuse which can happen beyond what your traditional security solutions can protect you against. So today, I think it's quite well accepted that you need a firewall, you need a web application firewall, you need a web API gateway. But what is less implemented is this specific security solution for API security to protect you against this type of low and slow logic style abuse. And this security solution need to be able to detect behavior. So it's not detecting signature because it's not in itself a single API call can't identify whether it's a malicious actor. You need to collect, let's say, a series of API calls, and then you need to analyze the behavior to know whether it's acting maliciously. So a lot of times, these type of solutions will will collect the API data, store in the API data lake, and then run some sort of AI/ML models on it to detect anomalies. So this solution will be able to detect APIs in your environment, will be able to protect you against this OWASP API top 10 risk. So and it does that through detecting through AI/ML models. Yeah, and a usual architecture would be to put a sensor where most of your API passes through. So find a choke point and then collect those APIs and then do the data lake where your API AI/ML models can run. Yeah, and just a use case maybe by a network operator. So a network operator perhaps might release APIs for end-to-end network orchestration. Yeah, I mean, you could release it via in a form that is standardized. So these APIs, again, let's say you release to your partners or vendors or whatnot, it could be potential open door abuse. And this API might be written with some vulnerabilities in them. So how do we detect that? You must, first of all, collect all the APIs when they are passing through, and then run it into a security data lake. Here, you can run whatever models you want, your AI/ML models, to detect malicious user behavior. And if a user is trying to, let's say, scrape data, or let's say trying to change a setting which they are not authorized to, then perhaps it could be detected. So yeah, in summary, network operators are increasingly using APIs, I think, across all aspects of the organization. So perhaps a blind spot could be this particular thing called API security, low and slow logic style attacks. So I presented a potential architecture where how to detect this type of issues. Yeah, thank you. Any questions?
Okay, thank you. Okay, are there any questions? So I can ask a question then. So, I mean, I think it's very concerning that to listen to this and actually so how easy it is to gain some of this information. Now, perhaps I understand more the the security permissions on objects. Somebody's misconfigured something. I guess that's relatively easy to do, but what do you think are the reasons why too much information is being released through an API? I mean, there's some stuff there that should never be made public. And what do you think are how can that be addressed? How can you educate the developers or the programmers or whoever is putting this information into the system to do this better? Because this seems like a really basic error to me.
Yeah. I mean, totally, yeah. So I think this is a problem of misalignment in incentives. So what are developers usually incentivized? They are incentivized to feature velocity, speed, to get the product out quickly. And this is why they make design, maybe they put too much information, or they don't check every field whether it's authorized with the right token, right? That's right. If you log in with a token, sometimes you can access somebody else's wallet. You can sell things which you don't own because the developer didn't check. And why didn't they did a comprehensive framework of checking everything? Because it takes time, it slows down feature velocity. So organizationally, there had to be a right incentive alignment for their developers.
Okay. Give anyone else an opportunity to ask a question before I ask another question. Looks like there aren't anyone at the mics, but so you mentioned an API security architecture, and you gave some suggestions, but and you also mentioned OWASP as well, and I know that's one of the organizations that are involved in this. But is there actually, you know, a sort of a recognized standards being developed for this at all? You know, is this something that's become, you know, there's a best practice in the industry best practice or industry standards being developed, or this is just something that I think we're suggesting at the moment?
So this is quite new. The OWASP API top 10 is some sort of industry standards of what are the usual attacks people are happening. So that is they collect data from the community and they rank it. So that is what's happening. As to how to address this, I think most people have gone towards these behavioral models, AI, ML, to detect this type of attacks because, like I mentioned, a single API call by itself, you can't judge whether it's malicious or not. You have to look at it over time. So most people have resorted to some means to either collect it over time, and they use various machine learning models to tell whether it's malicious or not.
Okay, thank you very much. Don't see anybody at the mics, so again, thank you very much for your talk. Okay, so that brings us actually to an early end to this session. I believe it's now lunch, so please come back after lunch for the next session. And again, thank you to all three speakers.